This presentation covers LPDDR2 and LPDDR4, which can be great solutions for many applications. We'll also touch on other DRAM offerings from ISSI, plus more in depth about an optional feature from ISSI called On-chip ECC. ISSI has a wide offering of mobile DRAM, starting with mobile SDRAM, single data rate, which requires a voltage of 1.8 volts, 2.5, or 3.3 volts, LPDDR, and of course LPDDR2 and LPDDR4 and 4X. However, ISSI also has a variety of other DRAM like EDO and fast page, SDRAM, DDR, DDR2, DDR3 and 3L, and higher speed DDR4. In addition, ISSI offers specialty DRAM for networking like RLDRAM2 and RLDRAM3. Low power DRAM has evolved quite a bit over the years. As performance requirements have become more demanding, speeds have increased. Power consumption has decreased. Features have advanced in each generation to enable flexibility and ensure data integrity. ISSI offers LPDDR2 in densities from 256 megabit to 4 gigabit. The clock frequency can run up to 533 megahertz, which is a 1066 megabits per second data rate. Packages offered are 134 ball BGA and 168 ball pop BGA, and the data I/O is either by 16 or by 32. This roadmap shows the lower density range of the LPDDR2 offering from ISSI. It shows that ISSI will be offering this for many years, through 2027 and beyond. Standard temperature grades are commercial, industrial, and automotive. The A3 grade goes up to 125 degrees C. This is this other page for the roadmaps. This shows the densities from 2 gig through 8 gigabit. Currently in production are 2 gig and 4 gig, with new generations on the way. In 2021, ISSI will be introducing an 8 gigabit density. ISSI has an offering of LPDDR4 DRAM from 2 gigabit through 8 gigabit currently. There's a separate offering for either LPDDR4 or 4X. The difference is the voltage for the I/O. The LPDDR4 requires a 1.1 volt I/O, where the LPDDR4X requires a 0.6 volts I/O, whereas both require 1.8 and 1.1 volts. There's either a single channel, also known as by 16, or dual channel by 32, but there's one package, which is a 200 ball BGA for everything. This is the first of 2 roadmaps for LPDDR4, showing 2 gig through 16 gig plans. Currently in production are the 2, 4, and 8 gigabit shown there. The maximum data rate for the current time is 3200 data rates, megabits per second. In 2021, ISSI is planning to introduce a faster data rate of 4266 and also a 16 gig density. This is the LPDDR4X roadmap, very similar in timing to the LPDDR4. The difference is the part number. Please note the AL in the part number, showing that it supports LPDDR4X voltage of 0.6 volts I/O. There's many chipsets that support either LPDDR2 or LPDDR4. Please take a look. Ambarella, Intel, and Mobileye all have SoCs or processors that support one or the other, as well as DDR3 or DDR4, whichever the case may be. This list includes NVIDIA, Renesas, Texas Instruments, and Xilinx. This is not meant to be an overall or complete list, but just gives a few examples. A development board that supports LPDDR2 or LPDDR4 includes the following. This one is Intel, the Max 10 development board that uses a 1 gig LPDDR2 from ISSI. Here's a Mobileye IQ3 for automotive cameras. It uses 2 1 gigabit LPDDR2 from ISSI. This one is an NXP IMX8 quad development board, which uses an 8 gig LPDDR4 from ISSI. And this one is a development board from Trends. and features a Sync UltraScale Plus from Xilinx, as well as an ISSI 8 gigabit LPDDR4. Next, we move on to one of the huge value-added options from ISSI, LPDDR4 and 4X with ECC. In almost every application, a memory error can be a problem. It is important to ask, what if an error happens? The result might be minor, as in multimedia, where a bit flip is simply a pixel that changes color or noise in the audio stream, or the result might be very significant and dangerous. Topics related to errors are considered, such as what is the risk of an error? How can the error be detected? And can the error be prevented? And what should be done if an error does happen? When it's necessary to prevent the error, one of the most popular strategies is to use data redundancy, so that if one bit in the memory has an error, there is enough data that's still valid to determine what is the correct data supposed to be. The algorithms to encode the data into memory happen during a write, and the decoding happens during a read from the memory. Together, this process is called error correcting code, or ECC for short. The conventional approach is to add a component of memory. Please refer to the examples. The main memory are the blue rectangles, where the extra memory is the white one. This can be a good solution, and it has a long history of working well, especially for DRAM like DDR3 or DDR4. In this case, the standard memory is 64 bits wide, where the additional component makes the total 72-bit wide. On the other hand, for LPDDR4, the scheme is usually where a single component represents without the ECC, but adding ECC requires a second component. Not all processors or SoCs do support this approach for ECC. Another solution from ISSI is On-chip ECC. In this case, we'll show a comparison. The above diagram represents the traditional approach of having a separate component for the ECC, and the lower diagram is the on-chip ECC. This latter approach of having on-chip ECC can add flexibility and solve a problem. In the upper board, there's 32 bits of data for the standard memory. This is what it would be without the ECC. In order to support ECC, a second component is added, with blue and gray in the rectangle. Only 8 bits of that component is implemented, while 75% of the memory is unused. The controller side uses its ECC generator and checker alongside the memory controller. The key is that in the lower diagram, the ECC error and checker moves to the ISSI DRAM. Everything is managed by the DRAM, along with the storage of both the data and the ECC bits. Another advantage is that any and all microprocessors and SoCs can use the DRAM with ECC, as they do not need the ECC block. Also, the second DRAM component is unnecessary, as data in ECC is all consolidated. This saves board space and routing complexity. The on-chip ECC has additional features for the ECC event, which will be covered later. The conventional approach can still be the best solution in many cases, but there are some situations where ISSI's LPDDR4 and 4X with on-chip ECC might be best. The first one might be if the memory requirement can go from 2 components to 1. This can save a lot of board space, power, and cost. Another one is if the microprocessor or the SoC does not support ECC, or if the data bus that it does have is too narrow to carry the additional ECC bits, or if the ECC algorithm adds too much resource allocation for the microprocessor. And lastly, in some cases, additional ECC event data may be required by the processor or the application. What is ECC event data? This is all data that's related to the error. ISSI does support information that's related to the ECC event. And by the way, this is all optional. Some of the additional ECC event data includes an error signal to alert the application if an error does happen. An ECC status register can store the ECC event data, such as the type of error, whether it's single or multi-bit, and also the ability to turn on or off the ECC function for testing, perhaps. And if using the status register, there may be two ways to access it, either an I2C bus or a mode register command. Here's the overview of the ISSI LPDDR4 and 4X with On-chip ECC. All products shown there are in production, except for a 2 gigabit dual channel, which is currently sampling. Let's take a look at the roadmaps with LPDDR4 with On-chip ECC. The plan is to offer these products for a very long time. Standard temperature grades include industrial and automotive, as many of these products are required for the automotive applications. LPDDR4X with On-chip ECC is also shown here, with a similar roadmap and also temperature grades. In conclusion, the ISSI LPDDR2 or LPDDR4 can be great solutions because of their very low power and high data throughput. There are a wide variety of SoCs and microprocessors that do support LPDDR2 or LPDDR4. And if ECC is important, ISSI's offering of LPDDR4 and 4X with on-chip ECC can be a great solution as well. And finally, if neither one of these is good for the right solution, ISSI also has a broad portfolio of DRAM with long-term support and high quality. If there are any questions, please either contact the ISSI marketing team at dramissi.com or ISSI sales team through the website. Thank you.